Hello, you are welcome to Chemistry Hangout. I want to believe we are doing very fine today. If you are just watching this YouTube channel for the very first time, you are in the right place. This is a place where we bring the knowledge of chemistry in the simplest way so that you can understand with simplicity. So if you are just watching this YouTube channel for the very first time, you are actually in the right place. Click the subscribe button. You can like the video, share the video, and your comments will be appreciated. And if you are already a subscriber, I want to welcome you chemically to this very wonderful series again of teachings on chemistry hangout. I started a series in my last video. I was talking about how to answer chemistry questions because I discovered even some students, as much as they understand the subject matter, they cannot accurately answer chemistry questions. And this will help a lot of people that are writing GC, you're preparing for JAM, you are preparing for WAEC, you are preparing for NECO, you are preparing for external examinations, and even undergraduate. You are studying chemistry related course. The understanding of all these teachings are very, very important. So I welcome you again wonderfully to another teaching series on chemistry and I want to believe you are going to be very, very blessed after the end of teaching. Pay maximum attention to today's class so that you will understand the full teaching of what I have for you for today. So pay maximum attention, relax, and I trust at the end of the teaching you are going to be very, very blessed. So let's see the question I have for us for today. I want us to pay maximum attention. So it said element X and Y are represented as 4020X and 1618Y respectively. For each element, write one, the electronic configuration using the SPD and F notation, the number of unpaired electrons. Let's take it one after the other. Now, I will be doing some teaching alongside and I'll be answering the question. So I want you to pay maximum attention. I've told you, when it comes to electronic configuration in chemistry, it is very, very important because it cuts across a whole lot of topics. And the problem I see a whole lot of students has is that when your foundation is not that solid, yes, when you don't have a solid foundation, then you're going to be finding a whole lot of topic difficult. Imagine you don't understand electronic configuration, you cannot do chemical bonding, you cannot do periodic table, you cannot do oxidation number, you don't understand valency, and these are what just that topic electronic configuration covers. So I'll be doing teaching alongside and I'll be explaining how to actually answer the question. Now they said element X and Y are represented as this. We must have been taught, or if you have not, if you have not had that before, or you've not been taught that before, then listen. If you see any inscription in chemistry that you have something like this, and you have a number here, you have another number here. Let me just say you have, let me say this place is, let me say 12, and let me say 6. If you have an inscription like this, the meaning of the X represents the symbol of the element. X could be any of the element symbol in the periodic table. While the number up here beneath is the mass number. The number here is the mass number and the number here is the atomic number. I want to believe that is clear. So with this now, X is representing an element. They did not give us the symbol. So, but we know 40 here is the mass number, 20 here is the atomic number, 16 here is the mass number, 8 here is the atomic number. So they are representing it by X and they are representing it by Y. Now listen and listen very carefully. Them representing this by X and Y doesn't mean that they don't know the element. They know. But please make do with what they have given you. Some people will change at the end of the question. Some people will come and change the S to calcium because calcium is atomic number 20. No, you are wrong. Make do with what they have given you. They are assuming the elements to be X. They are assuming the elements to be Y. It's fine. I hope that is clear. So don't come and change the element because you know the atomic number 8 in the periodic table, you know the atomic number 20, you are not trying to change. No. Just make do anything you want to talk about as far as this question is concerned. We refer to X and we refer to Y. I hope that is clear. So the answer for each element, write one, the electronic configuration using the SPD and F notation. You can see they are specific because when you want to write the electronic configuration, you can write it in the shell method where you have, where you have maybe 281, where you have 2881, these notations are the K element shell notations, but they were specific. They said write it with the SP, D, and F notation. I hope that is clear. So if you are writing it like that, if you have not checked my last series, then please kindly check it. If you have not checked my last series, I talked about the rules governing writing of electronic configuration using the orbital method. I talked about the Pauli exclusion principle. I talked about the Afroba's principle. I talked about the Un's rule. And this same rule is what we are going to be using to answer this question. You see that? So if you have not studied that, go back to my video and understand how to actually use that rule. So I want to write for X now. So number 1, for X, I'm using those rules. So this is atomic number 20. So I will have 1s2. I will have 2s2, I will have 2p6, I will have 3s2. So let's count. 2, 4, 10, 12. Can you see that? 1s2, 2s2, 2p6, 3s2, 3p6. Let's count now. 4, 10, 12, 18. Then we can now have 4s2. If you don't understand how I actually got this, go back to my video. I have done this. There's a topic on the channel. Electronic configuration of atom is there. The last series I did, I explained this too, so it's very clear. This is just the Afroba's principle. This is the Afroba's principle. You are moving from lower energy to higher energy, so we are using Afroba's principle to actually do all this. If I need to now draw the orbitals, I will now be considering Pauli exclusion principle and Un's rule. Pauli exclusion principle, spin up, spin down. I hope you should understand that statement. I've done that. Un's rule, filling singly. So all these I wrote now, I just use that for mass principle. But if I want to draw, I need to apply Pauli exclusion principle. I want to draw the orbital, I need to apply Pauli exclusion principle and Un's rule. I hope that is clear. So for X, 2, 4, 10, 12, 18, 20. Correct. 20. Very correct. So for Y is atomic number 8. So we have 1s2. We have 2s2, that will be 4, then we have 2p4. You know, this is atomic number 8, so this 2, 1s2 exhausted, 2s2 exhausted, then 2p4, because the number of electrons remaining is not up to 6 again. Don't forget that our S can contain maximum number of 2, our P can contain maximum number of 6, our D can contain maximum number of 10. I'm talking about electron now. And our F can contain 14. This is the maximum number of electrons you can have in those orbitals. S can contain maximum number of 2, P can contain maximum number of 6. So if P can contain 6, definitely it can contain 4. Very correct. So for the electronic configuration using the SPDF notation, that is sorted. So number 2 now, they now say the number of unpaired electrons present in the atom. They did not ask you to draw the orbital. They ask a specific question, the number of unpaired electrons. So you can draw it the way you want to draw it, just provide them with the number of unpaired electrons. And how do you get that number 2 now? Very simple, very, very simple. Don't forget, the number 2 question is the number of unpaired electrons present in the atom. So how do you get the number of unpaired electrons? They did not ask you to draw any orbital. So you can, I've said that earlier, you can just draw it somewhere. It's not part of what they will give you mark for. Even if you draw the orbital here, they will not allot mark for you because they didn't ask you to draw it. So how do you get that? Very, very simple. For X, what is the number of unpaired electrons? Because the meaning of this thing you have written is that this place is filled up already. That's why you move to the next. This place is filled up already. That's why you move to. That's the meaning of what we have just done. So which means these are filled up already. So we are going to the last orbital, which is 4s2. So that 4s2, no, 4s2. I'm just drawing this so that you understand. 4s2 means you are going to have a spin up and a spin down. So which means this is paired already, because when you say something is paired, that means they are coming in twos. So this is paired already. So they are now asking the number of unpaired. So the number of unpaired electrons here is 0, because all electrons here are paired already. So I can say S has 0 unpaired electron. I hope that is clear. Meaning, the meaning of what you are saying is everything is paired. So there is no unpaired there. So X has 0 unpaired electron. Let's come from 1. Don't forget, this is filled up. This is filled up already. That's the meaning of what we have done. So 2p4, p4. Don't forget, p you divide it into 3 because you can have 2 in each. And don't forget the rule. I did this in the last video, and this is the importance of all these things. So our 2p4 Moore's rule, very important. You feel singly. You are having 4 electrons. So we have 1, we have 2, we have 3, and we have what? 4. Can you see that? So how many paired do we have here? Just 1. How many unpaired do we have? 2. You have 2 electrons that are unpaired, but this one is paired. But what did they ask us in the question? The number of unpaired electrons. So we have 2 unpaired electrons. So meaning Y has 2 unpaired electrons. Y has 2 unpaired electrons. That is sorted. Very clear. Okay, the next one. They said the orbital in which the valence electrons are found. Valence electron is the outermost electron, and that's obvious because if you look at this, the valence electron will be this. This is the electron that is outside. So which orbital are they going to be found? That's the question. Very simple question. So our X, don't forget the orbital in which the valence electron are found. For X, the valence electron will be found in the 4s2. Can we prove that? Yes, we can still prove that with, don't forget our 20. If you do the k element shell, we are going to have 2, 8, 8, 2. Do you still remember this? So which means you have 2 the first shell, 8 the second shell, 8 the third one, and this is the last shell. So 2. So these 2 electrons will be before it. That's the unit. So very, very clear. So for Y now, still same question. The orbital in which the valence electrons are found. So we have identified for X, that's the 4s2. For Y now, what will be the orbital in which the valence electron will be found? A whole lot of people will just write only 2p4. You might be penalized. If you write only 2p4, you might be penalized. Because what you are telling us that the number of valence electrons in oxygen is 4 and it's not 4. Why? If you look at this, oxygen is atomic number 8. I'm just using that as an example. They didn't give us the element, but since they said atomic number is 8, that's why I'm using it to explain. So we have 2 and we have 6. Can you see that? So the valence electron, which is the electron in the atmosphere, altogether are 6. So if you write only 2p4, it means you are recognizing 4 and you are leaving behind the 2 which is remaining. So for us to get the full mark, we can tell them that the valence electron, the valence electron is 6, which means it will be this and this. So the valence electron will be in the 2s2 and the 2p4. This is where the valence electron will be found because this is 6 already. So if you write 2p4, you might be thinking it is 4 that is in the outermost electron, which is actually wrong. So the valence electrons are 6, so it will be in the 2s2 and it will be in the 2p4. I hope that is very, very clear. So that is clear. So let's move on. I hope you understand this. So very, very important. So the valence, the orbital in which the valence electron will be found for Y will be this and this, because the electronic configuration using the shell is 2, 6. So we have 6 in the outermost shell, and I will explain why this thing is important here. Now the answer, the group and period to which the element belongs. Can you see? The group, that's a topic on its own. There's a topic we call periodic table. I will still be coming here, soonest to dissect that very particular topic. It's a wonderful topic in chemistry. In fact, without periodic table, chemistry might not exist, because that's where we have all our elements. So, but let me just quickly explain something, because if you check the periodic table, you see the way they arrange elements, according to their atomic numbers, hydrogen, helium, lithium, beryllium, like that. So, then I said, the group and period to which the element belongs. How do you get the group of an element? We are still talking about the valence electron. Can you see? So, the number of valence electron in the outermost shell of a neutral atom is the group. What am I trying to say? Look at this. I gave something when I started for X. I gave the electronic configuration, which is 2, 8, 8, 2. Can you see these questions are, they are just coming into themselves. So you must understand the rudiment. You must understand chemistry rudiment. The basic, the fundamental things in chemistry, you must understand. Now look at this. This is the electronic configuration using the shell method. And ask what is the group? The group is this. How do I know? Because this is the valence electron. This is the electron that is outside. So the number of valence electron outside represents your group in the periodic table. So if you go and check This is 20. If you go and check element 20, which is calcium in the periodic table, you're going to be finding it in group 2. Can you see that now? So, and if you check the period is the number of shells that you have. So this number 1 shell, number 2 shell, number 3 shell, number 4 shell. So X, I'm moving to 4 now. So X will be in what? In group 2, period 4. I hope that is clear. How do I get the group? The number of electrons that is outside. It's just like, can you see? The number of electrons that is outside 2, while the period 1, 2, 3, 4. That's how. So if you go and check atomic number 20, which is calcium in the periodic table, you're going to find it in group 2 and in period 4. That is very clear. I hope this is clear, very clear. Okay? Now for Y, then we should be able to tell me for Y. For Y now, don't forget Y is atomic number 8. So the electronic configuration is going to be 2, 6. Can you see that now? So what is the number of electrons you have outside? That is 6. So which means Y will be group 6. I hope this is clear. What will now be the period? Count the number of shells. 1, 2. So it's going to be period 2. I hope this is clear. It's going to be period 2. So we need all this knowledge, all this fundamental knowledge in chemistry, the rudiments. We really need them. And if you look at the questions, they are just, they're just entering into themselves, just trying to check for how much you understand chemistry basics. And this is what all these things are actually after. So the group, the number of valence electrons you have, let's say for example I have like carbon now, carbon is 6, that will be 2, 4. You need to know all these things. So what will be the group? The group will be the 4, which is the valence electron that is outside, while the period will be 2, which is the number of shells. That's how we get our group and our period in the periodic table. So if you see any question asking for group and period, just do the electronic configuration. I have a video on the channel that talks about this electronic configuration, so you can check it. So that is that for that. Okay, let's move on. The type of bond that would be formed between X and Y. I love this question. The type of bond that would be formed between X and Y. Let us look at X. If you look at X as an element, let me explain something here. X is now 2, 8, 8, 2. I'm just explaining the ask of this. I'm just, reiterating what I've done before. Y will be 2, 6. Look at this. You should understand that there is an octet rule or there is a duplet rule in chemistry, meaning these elements are not stable. Why? Because they have not attained what we call the octet rule. Are we together now? So which means this S, we have tendency to donate these two. If X donates these two, the electronic configuration becomes 2, 8, 8. Can you see that? So if X donates these two, it becomes S2 plus. Because when you donate in chemistry, when you give electron, you become positively charged. Look at Y. Y2 want to attain octet structure. So what happens? Y will collect the 2. So when Y collects the 2, Y becomes Y2 minus. Can you see that? So there is difference between, this is an anion now, this is a neutral atom, meaning this has given 2, that's the meaning. So when this gives this 2, it becomes stable. When Y collects the 2, Y becomes 8. So this one becomes, this now will now become 2, 8, because it has collected 2. While this one will become 2, 8, 8. And that's what forms what we call valency in chemistry. I'll do a series on that. I'll do a series on valency and naming inorganic compounds. I'll do a lot of teachings on that, maybe after this very particular series. Okay, so we want to look for the bond that is formed. Now look at that. 2 is now positively charged because it has given. Y is now 2 minus because it has collected. Look at this. Any kind of bond that involves transfer of electron, because 2 will be transferred to this, so that this will be stable. The 2 that will be transferred to this add up to this 6. These 2 will be stable. Can you see that? So any bonding that involves transfer of electron, we refer to it as an ionic or electrovalent bond. I have done chemical bonding on this channel too. You can check the videos on the channel, chemical bonding. I explained the 5 bonding that we have. Yeah, I think I explained 5. I explained electrovalent, I explained covalent, I explained coordinate covalent, I explained metallic, I explained hydrogen bond, yeah, I explained van der Waals. So I explained 6 of those bonding explicitly, so you can check the channel. So for this one, they said Name the type of bond that would be formed between X and Y. So that would be the fifth question. That will be the fifth question. So what kind of bond will be formed? Having explained all these, what kind of bond will be formed between X and Y? Because it involves transfer of electrons, so it's going to be an ionic bond. And it's still the same thing. If you write electrovalent bond, you are still correct. Any of these is correct. So ionic bond. Why? Because you have transfer, and that's why we said it's ionic. Because at the end of that process, they become positively charged and negatively charged, so they become an ion. So that is that. So the last one now, which is VI, they said write the formula of the compound formed above. I have seen a lot of students do a lot of errors here, error here, because some of them will now be using the name of the element. No, they are assuming that the element is X and Y. I hope that is clear. They are assuming that the element is X and it is what? It is Y. So don't forget, let me do this. So don't forget our S has given 2, do you still remember? And our Y has collected 2. So look at that. What kind of bond will be formed between them? So it's just like the 2 plus is balancing the 2 minus. I hope this is clear. So the kind of bond that will be formed will be SY. Now look at this. Let's take for example, S gave 3. I'm just using this as an example. And Y collected 2 each. It is possible. Maybe S gave 3 and Y collected. If you want to state the kind of bond form, they will exchange their valency. The reason why if this one exchange their valency, just like you are cancelling plus 2 and minus 2, that's how I'm getting XY. Do you understand? So, but let's say for example, S is giving 3 each and Y is giving 2 each. They will exchange their valency. So the kind of bond form, if I want to represent it, it will now be X2, Y3. Can you see that now? So it will be X2, Y3. They will exchange. But the reason why this one is just XY is because it's just like 2 plus, 2 minus. They're just cancelling each other. So they're going to get this. Let me give an example. If I have likes of maybe, aluminum used to give 3 and oxygen used to collect 2. Do you see that? If I want to state the kind of bond form here, or let's say this one is X also, and this one is Y. I'm still giving an example. It will now be X. You can see X is giving 3. Y is collecting 2 each. So they will exchange their valency. So it becomes X2, Y3. Can you see that now? So this is a typical example of what I'm explaining. So, but for this, because they are giving 2, they are collecting 2. So that's why we are just cancelling them. So they are going to form SY, not S2Y2. If you write this, it will be wrong. Because it's just like the 2 that is giving is being collected by that other one. So they cancel out each other. Do you see that now? So if you write S2Y2, you will be wrong. The formula that will be formed will be XY, which means that if X is calcium, I'm just explaining that just for our understanding anyway. So which means if X is calcium, which is 2 plus, and O is oxygen, which is 2 minus, the compound that will be formed will be CaO. And this is what? Calcium oxide. Can you see? So if you now write this, that's a chemistry blunder. This is a chemistry blunder. Because if you put your 2 S to Y2 here, this is what you are writing, which is wrong. So because this and this, they just cancel up each other. Plus 2 minus 2, they cancel up each other. If I have, let's say for example, I have this plus, can you see? Cl minus. You can see, just cancel up each other. They have NaCl because they are just 1. This is the same thing as plus 1. This is the same thing as minus 1. So they cancel each other. So that's how we write compounds in chemistry. So the compound that will be formed is XY. Can you see that? And that's the question. That's the question. So very important. The main bone of contention here is understand electronic configuration. Very important. Understand how to write electronic configuration using the shell. That's 21, 281, 282. Understand that. Understand how to write electronic configuration using the SPDF notation too. Very important. It will help you in understanding valency. It will help you in understanding electronic configuration. It will help you in understanding chemical bonding, and that's where students find difficult. When you don't understand all these rudiments, then you're going to be finding a lot of things difficult. So if you have a question like this, I am sure GC students, YX student, ECO student, there is no way. Chemical bonding is a very important topic in chemistry. You might be getting questions on them, but it might not be like this. But this is just a clue of if question comes like this, how to actually tackle them. So once again, this is Chemistry Hangout. I love you guys. Thanks for your prayers. Thanks for your motivations. If you're already a subscriber, I love you. If you're watching this YouTube channel for the very first time, do well to subscribe to this channel. Till again, when I'll be seeing you on this channel, have a very wonderful day. I love you.